In the quadratic formula, x equals negative b plus or minus square root of b squared minus 4ac all over 2a, the value underneath the square root sign is called the discriminant. The discriminant equals b squared minus 4ac. The value of the discriminant, if you were to calculate just b squared minus 4ac for any given quadratic equation, tells us how many and what kind of zeros a quadratic equation has. For example, if the discriminant is a positive number, then the roots of the quadratic equation are going to be two different real numbers. If the discriminant is 0, the quadratic equation will have one real number as a root, and if the discriminant is a negative value, then there will be two complex conjugates as the roots in the form of m plus ni and m minus ni. And that makes sense because if the discriminant were negative, it would mean this value under the square root would be negative, which tells us that there are imaginary numbers involved. So let's try calculating the discriminant of a few of these quadratic equation examples over here. We have y equals 2x squared minus 2x minus 12. A is equal to 2 in this case, b is equal to negative 2, and c is equal to negative 12. Our discriminant equals the portion under the square root sign of the quadratic equation, which is b squared minus 4ac. So all we have to do is plug in our values for b, a, and c into the discriminant formula. That gives us b is negative 2, so negative 2 squared minus 4 times 2 times negative 12, which equals 4 minus negative 96, which is actually 4 plus 96, and the discriminant in this case is 100. Calculate the discriminant of the following quadratic. G equals h squared plus 4h plus 3. We'll try one more example. In this case, a equals 1. There's no coefficient in front of h except for an understood 1. b equals 4, and c equals 3. Again, discriminant equals b squared minus 4ac. And that gives us, in this case, 4 squared minus 4 times 1 times 3, which is 16 minus 12, and our discriminant in this case is equal to 4.